In this lesson, we're going to look at solving right triangles. And we're going to take what we've learned so far about the sine, cos, and tan ratios and put it all together. So here is simply an example of where you might use trigonometry again. The polar aurora is one of the most beautiful and impressive displays of nature. There have been various attempts to explain the phenomenon of these northern lights. Carl Stormer, a Norwegian scientist, used a network of cameras to simultaneously photograph the aurora. He used the photos to measure the parallax angle shifts and then calculate the height of the aurora. There are a couple of terminology pieces that we need to be very clear on when we are going to do application questions. The line of sight is the invisible line from one person or object to another person or object, and it is a horizontal line. Some applications of trigonometry involve an angle of elevation and an angle of depression. So if we're talking about an angle of elevation is going to be based off of a horizontal line, so your line of sight, and if they refer to an angle of elevation, we are talking about an angle that is above this horizontal line. So we're elevating. Whereas an angle of depression is when you have the horizontal line and your angle is going below that line. So we call it an angle of depression. A couple of things to note. Sometimes these angles don't represent the part inside the triangle. But notice this. We are dealing with a 90-degree angle. So if you are given the angle of depression, you can find the angle that's in the triangle by going 90 minus your angle of depression. The other thing to note, this is a property you will learn actually if you take Foundations 20. We have angle of depression and angle of elevation if we join our horizontals. These angles here, your angle of depression and your angle of elevation, will be the same. So that's another thing to keep in mind. What we have here is Sam wants to calculate the height of the First Nations native totem pole. He positions his transit 19 meters to the side of the totem pole and records an angle of elevation of 63 degrees. Now it's kind of hard to see in this diagram here, so I'm going to actually draw it again off to the side. But what we have is he positions his transit 19 meters to the side of the totem pole. So here's his transit. What he then does, he records an angle of elevation. So we have our horizontal right here, and the angle of elevation is the angle that goes above this line, and that is 63 degrees. We also know that the height of Sean's transit, Sam, is 1.7 meters. So what that means is his transit is starting 1.7 meters above the ground. So we're going to have to take that into consideration at the end. What we want to determine is what is the height of the totem pole. So what we are going to do is we are going to look at what we're given. We know an angle measure, we know a side, and here we are looking for the measure of that side. So we now need to label our triangle. Here is our right angle. Remember, the side across from the right angle is your hypotenuse. The angle that we are given is the 63. So the side across from angle 63 is called our opposite side. The side that is beside angle 63 is called our adjacent side. Now the pieces of information that we know the adjacent side, we are looking for the opposite side. So you need to think back to your 3 trig ratios and think about which trig ratio uses adjacent and opposite. And the answer is tan. Tan of an angle is equal to its opposite measure divided by its adjacent measure. So this is the ratio that we are going to use. So what we have, we know the angle measure is 63. So we've got tan of 63. The opposite side is what we are looking for, so we've assigned a value of x to it. The adjacent side was 19. So now we can solve this. Make sure your calculator is in degree mode, and then you find tan 63. So you either go tan 63 equals or 63 tan. Either way, you get 1.9626 equals x over 19. And now we have a linear equation to solve. We want to eliminate the fraction, so we multiply both sides by the denominator. So we have 19 times 1.9626 is 37.2894 equals, the 19s cancel out, and we have equals x. Look back to see, what were we supposed to give our final answer? To the nearest tenth of a meter. That means 1 decimal place. So 37.3 meters. Now we need to think about this. What was it that we found? We found this side of the triangle right here. But the extra information in the question was that the transit started 1.7 meters off the ground. The totem pole actually goes all the way to the ground. So the height of the totem pole is 37.3 plus 1.7. So it is 39 meters. There's the height of the totem pole. So what you want to do, you want to label the sides of your triangle according to the angle measure that you are given. So according to that 63, we labeled it opposite, adjacent, and hypotenuse. Then we looked for the values we were given. We were given 19, which happened to be on the adjacent side, and we were asked to find the height, which was the opposite side. So you go back to your 3 trig ratios and you ask yourself, which ratio uses adjacent and opposite? And it was tan, so now we can proceed. In this one, Natalie is rock climbing and Aaron is belaying. When Aaron pulls the rope out to the ground, the angle of depression is 73 degrees. If Aaron is standing 8 feet from the wall, what length of rope is off the ground? So what we have to do here is we have to understand this question. So Natalie is rock climbing. So here is our wall that she is rock climbing on. Aaron is belaying. He is off the wall. He is 8 feet from the wall. He is holding the rope for Natalie. Now here's what we have, the angle of depression. So what we have to do is we have to draw in a horizontal line at the top. And remember, angle of depression goes down. They tell us the angle of depression is 73 degrees. Now that angle measure is not in the triangle. But remember what we can do. We can find the missing angle right up here by going 90 minus 73. So we know it's 17 degrees. What is it we are trying to find? We are trying to find the length of the rope. So right here, we want to know the length. So now what we need to do is we need to label our triangle. Across from the right angle is the hypotenuse. Across from the angle we are dealing with is our opposite side. Beside the angle we are dealing with is our adjacent side. So, what is the information we know or are looking for? We have our opposite side. We are looking for our hypotenuse. So you need to think about your 3 trig ratios and which of them uses opposite and hypotenuse. The answer is sine. Sine theta is opposite over hypotenuse. So what we do is we continue. Our angle measure is 17. Our opposite side is 8. Our hypotenuse is what we are looking for. We can use our calculator, making sure it is in degree mode. Sine of 17 is 0.2924 equals 8 over x. It is a linear equation. We solve it by multiplying by the denominator, which is x. And so we have 0.2924x equals, the x's cancel out, 8. And now we divide by 0.2924. And we get x is 27.4. So that is how much rope, and it is in feet, is out. So that's how much rope is off the ground, 27.4 feet. Now, just so you know, we could have solved this differently. If we think about our original diagram, we had our angle of depression of 73 degrees. Remember what we talked about in the initial terminology. We said that the angle of depression will be equal to the angle of elevation if you join the two horizontals. So we could have said that this one here is 73, this is still 8, and this is what we are looking for. But now when we label this, we have our hypotenuse, and this side is our adjacent. Which ratio uses adjacent and hypotenuse? Cos does. We could have solved this using cos, but we would have been finding cos of 73. So we are using a different angle, but your answer is still going to be the same. So just so you are aware, it could have been solved using a different strategy. So the key to these is to draw your diagram and then label your sides. Look at which two sides you are going to be using in the question and determine which ratio you need to use to solve.